Okay, so on this question, we're looking at what's called a rational equation. Notice it says solve the equation. Notice there's an equal sign there, right? So what's a little tricky is this can look very similar. Let me this line in so we can focus. And whenever I have an equal sign problem, I like to put the line. You don't have to, but just to help it jump off the page. The fact that there's an equal sign, a separation, a left side and a right side, so that we're clear on that. This is an equal sign problem. Now, what does that mean? That means whatever we do to the left side, we must do the same thing to the right side. Now, let me help you with this. What if instead the question was, let me put it over here, 7 over x, oops, what that was it funny, 7 over x plus, instead of equals, what if it was like that with no equal sign? That's what we did in the last section. And those are both going to be on the exam together, and it's easy to get them confused. So I want to help you with that right now even. Practice exam will especially help you with that when they're both there all mixed up, getting you ready for the real exam. But anyway, see the difference? This has got no equal sign, right? This was the last section. What was that? Was that 4.6. That was section 4.6. Remember those? We just finished 4.6. No equal sign. Remember what we did with those? If there's no equal sign, then there's no left side, right side. You're not thinking about left, right at all. What are you thinking about? Top and bottom. So here's my main point. In math, we're always keeping the balance. 2 ways to do that. Left, right, or top, bottom. How do you know which one you want to do? If you have an equal sign, then you do left and right, meaning whatever you do to the left, you do to the right. You don't even care about the bottom. You're not even thinking about top and bottom when you have an equal sign. You're just saying, hey, whatever I do to the left, I got to do to the right because the left equals right. Whereas on this one, which was, from last section, see how I made it the same thing? I just changed that equal sign to a plus. Then there'd be no equal sign, no left side, no right side. I'm not thinking left, right. So what am I going to think? Top, bottom. Top, bottom, meaning whatever I do to the top to the bottom. Well, what would I do to the top bottom? Well, I would come in here and I'd go 3. Top and bottom, right? Then that'd be 21 over 3x. This would stay as it is. What about this one? Well, this one's already over 1. So what do you got to do to him? Top and bottom. He needs the whole 3x, right? That'd become 12x over 3. See how I made all the denominators the same? By doing the top and the bottom, same thing, top and bottom, right? I did same thing, top and bottom on this guy, and this guy didn't need to do anything on the middle guy because he already had the common denominator. Now they all have the same denominator, don't they? Common denominator. That's what we did in the last section, right? That's what will be on the exam that we take, this next exam. So what would that be then? Then you just add them up. 21 plus 11 plus 12x all over 3x, right? There'd just be one big fraction because they all have the same denominator. And then you could just add these two. It'd be whatever that is, 32 plus 12x over 3x, done. Just like that. We just combine them together, put them all into one big fraction with a common denominator. How did we make that common denominator? We did the same thing to the top and the bottom so we don't change the fraction. Well, this one's going to be mostly different. Why? Even though he's so similar, and this is what people get confused about on the exam, is they don't spend enough time thinking about the differences here. So what's the difference? Equal sign, which means left side, right side. I'm not thinking top, bottom. All right, so what am I going to do then? Well, let's get back over here and let me do it. So how do I say it? Equal sign, well, rationals with an equals, yeah. Rationals, meaning fractions. Rationals with an equal sign. That's what we're talking about. What do you do when you have rationals with equal sign? Step number 1. What I'm going to do is I'm going to multiply the tops. I'm going to multiply all the terms left and right. Right? I'm not thinking top and bottom. Left and right by the LCD over 1. The least common denominator. What's the least common denominator? Same thing it is over here, 3x. So I'm going to multiply through by 3x. I'm going to go 3x over 1. Notice. 3x over 1 and 3x over 1. Everybody, so that's different, isn't it? You see how completely different that is? I'm not doing top. You might look at it and go, you're just doing the bottom by 1. That's not the same thing on the top and the bottom. No, it is not. Because I'm not even thinking about top and bottom. I'm thinking left and right. Why? Because I have an equal sign. So I have a left side and a right side, meaning this side equals that side, don't they? The left side equals the right side, which means I can multiply them all by 1,000,000 if I want to, right? If two things are equal and you multiply them both by 1,000,000, they're going to be equal again, aren't they? Just both 1,000,000 times bigger now. Does that make sense? You don't have to do the same thing to the top and the bottom here. You just have to do the same thing to the left and the right, right? If the left side equals the right side, which it does, then you can do anything you want as long as you do it to the left side and the right side. If they were equal before, they'll be equal afterwards, won't they? Does that make sense? And now this will actually be nicer and easier. Let me show you. Watch what will happen then. Now, x will cancel x. And so what do we have? 3 times 7, 21. What will happen here? 3x will cancel 3x. What do we have? 11. And what do we have here? 4 times 3x. And there we go. Look at that. We're almost done with this one. No more fractions. Do you see that? This is actually easier than the last section. You get rid of the fractions on the first step. Everybody see that difference? I'm not making the same denominators. I'm wiping out the denominator. Why? Because I have an equal sign. So I'm not thinking top and bottom. I'm thinking left and right. So that's the main thing you want to keep straight in your mind. If we have fractions, if there's no equal sign, like over here, right? No equal sign, that was last section. Then you got to do the same thing to the top that you do to the bottom, and you make all the bottoms the same, and then you combine them, right? That was the last section. But if you have an equal sign, you're not thinking top, bottom. You're thinking left, right. LCD over 1. Left and right, all the terms, left and right. And then cross cancel, and multiply what's left over. So there we go. Now, how do you finish this problem? Now, to finish this problem, let's go minus 11. We're here. Let me get rid of all this stuff now. Oops. A little bit better job on that. Okay, so now we just finish up the problem. Better job. All right. So now we just go minus 11. Right? I'm just solving for x. Now, right? X is over here saying, I want to be alone. Get rid of all this stuff, right? So I'm saying, okay. So this would be what, 10? Yeah. Bring down the 12x. And last step, divide by 12, right? Boom, boom. And then, so we've got 10 or 12. And then you can actually reduce that fraction, huh? Just divide top and bottom by 2 there. It's like going to be 5, 6, done. There's the answer to the problem, 5 over 6. So I want to make sure that difference is clear to you. They'll both be on the exam and you got to keep them straight. So when you have an equal sign, all you're thinking is left and right by LCD over 1. Left and right, all the terms left and right by the LCD over 1. We're not making a common denominator. We're wiping out denominators. It's really nice. After the first step, no more fractions. It's okay as long as you do the same thing to all the terms on the left and all the terms on the right. If they were equal before, you treat them the same. They got to be equal afterwards, don't they? That's different than when we don't have an equal sign. If we don't have an equal sign, then we don't have a left and right. We have to do top and bottom to make the denominators the same. So there we go.